Now, it is the whole frame after the motor is installed. Next we have to start adjusting the position of the motor. Because the motor position can now be turned, we can't judge whether it is in a horizontal state now. The first step in debugging is to confirm the position of the flight controller. Before determining the position of the flight controller, we must first determine the position of the drone head. Look at the arrow on the board. The position pointed by the arrow is the position of the drone head. This board also has such an arrow, and this board also needs to be installed. Make sure the arrow is pointing in the same direction as the arrow on the board below. First, use a screwdriver to screw the screws into the holes in the inner ring of the board. The outermost holes on both sides are for the final installation of the fixed cover. When installing the flight controller, we must ensure that its core position is in the center of the drone. There will also be an arrow mark on the flight controller. Make sure that the direction of the arrow is the same as that on the board. After adjusting and determining the position of the flight controller, we need to use double-sided tape to fix it. Then why don't we put the flight controller on the board below? Because if it is placed on the lower board, it will be very close to the electric circuit board. The electric circuit board will generate current, and the current will affect the flight controller. So we choose to put the flight controller on the board above. Now we stick the flight controller with double-sided tape. I'm just showing you how to do this now, so there's no need to stick it too tightly yet. But when we actually install the drone, we must use a very strong double-sided tape to stick it tightly. For ordinary double-sided tape, the quantity of these two pieces of double-sided tape is not enough. Ensure the firmness of the flight controller installation. The flight controller is equivalent to the heart of the entire drone. Now let's fix it. Make sure the arrow points are consistent, and make sure the flight controller core is in the center of the drone. After controlling the position, glue it on, so that the flight controller is fixed. Confirm again whether it is in the center of the drone and whether it is firmly glued. After the flight controller is fixed, we can start to adjust the position of the motor to make it in a horizontal state. This is the tool to be used for adjustment, the level instrument. We can use it to confirm whether the drone of the flight controller is in a horizontal state. Now we start to level the state. First, put the level instrument on the flight controller to adjust, and make sure that the drone is in a horizontal state before adjusting. Look at both horizontally and vertically. Generally, the data on the level instrument is displayed at 0.00, indicating that the best level has been reached, but within 0.2, it is considered to have reached the level state. Now we adjust the horizontal state of the motor. This motor is relatively small and not easy to operate. Generally, larger motors are easier to operate. After adjustment, tighten the screw. Follow the same steps to adjust the rest of the motors in turn, and tighten the screws to secure them up. After all motors are adjusted to the horizontal state in turn, place the level instrument on the flight controller to confirm the horizontal state. At this point, the horizontal state of our motor has been adjusted. Next, we start to debug the rotate direction of the motor. First, we need to connect the wires of the motor. The 3 wires on the motor and the 3 wires on the electric speed control can be connected to each other at will. As for whether the wire will be connected incorrectly, we can find out by observing the steering of the motor when we debug. If the rotate direction of the motor is wrong, we have to unplug and rewire. Just change 2 at random, so the wiring at the beginning can be ignored regardless of whether the plug is correct or not. Next, we need to consider where the signal line of the motor is connected to the flight controller. Different flight controllers have different motor connection positions. For example, our domestic flight controllers are generally M1, M2, M3, M4 in counterclockwise order, but the open source autopilot flight controller is generally based on this is M1, this is M2, this is M3, this is M4, so we must look at the requirements of the flight controller and pick them up as required. Now the flight control on this drone is from open source autopilot. Then we have to operate according to this is M1, this is M2, this is M3, this is M4. Now connect the signal line of this motor, which is M1, to the M1 marked on the flight controller. When connecting, it should be noted that this socket is a 3-pin. We have to observe its gap. The signal line should be connected to the gap, which is the light-colored line. Now insert it into AM1. As we can see, the white signal line should be connected to the side with a gap at the bottom. Then we connect M to determine the position of the M2 motor, just to connect this wire. Now we put it through the hole on the board to the M2 marked on the top of the flight controller. It is also the same operation to connect the white signal line to the side with a gap at the bottom. Next connect M3. This is the number 3 motor. Then this line needs to be connected to the M3 marked by the flight controller. Once again, I would like to emphasize with you that the numbering sequence of different flight controller motors is different. We must install the flight controller's manual to connect. The M3 has been connected here. This is the number 4 motor AM4. Connect the wire from the board to the flight control M4. There is still one wrong connection here. The white signal line must be at the bottom gap, and the black signal line must be at the top. M4 is also connected according to the same steps. The white wire and the black wire must not be wrongly connected, otherwise the drone will be out of control. Now we can pull the line down and tidy it up to make it look more beautiful. Here, the signal lines of M1 to M4 have been connected. After the signal line is connected, we need to connect it with power. Different flight controllers also have different wiring methods. Now I have the battery, which can be placed in the installed battery compartment. Be sure to hold the battery on the board. We also put a Velcro on the bottom of the battery. Now place it on the board of the battery compartment. Make sure the battery is in the middle of the board, it will be more stable. Then tighten the felt straps. The battery is now installed and can now be plugged up. There are two connectors here. One connector is for connecting the battery. The other connector is for the power supply of the flight control and remote control. Now let's connect. Different flight controllers have different PMU. In my hand is the PMU of this flight controller. First plug the wire into the power one, marked on the flight controller. You must read the flight controller's manual before operating. Strictly follow the manual to connect each line. Once the wrong connection will affect the normal operation of the drone. Then connect the wire on the battery. And the other head can supply power to the remote control. Here, the flight controller line is connected to the battery. We can see it. Now this battery can power the flight controller at any time. We'll fix the PMU later. Now we have to start judging if the rotate direction of the motor is correct. Also connect the connection between the computer and the flight controller. Different flight controllers also have different connection cable. Connect the line and turn on the computer. You can see the lights flashing on the flight controller, indicating that it has been powered on. This electricity comes from the computer, not from the battery. Our battery is not connected yet. Connect it now. Now the motor and electronic speed control are all charged. The motor rotate test can be performed on the computer. Help us judge whether the wiring of the motor is correct. Motor number 1 is a motor that rotates counterclockwise. We can use this guide to judge the rotate direction. We judge that rotate is not recommended to operate when the motor is equipped with a propeller. It is very dangerous. Tie the plastic ties to the motor. Then we use the debugging software of the flight controller on the computer to turn on the motor. It can be seen that the motor is rotating counterclockwise and the rotate direction is correct. Now take the tie off and test this motor. The number 3 motor should rotate clockwise. After turning on the motor on the computer, it rotates counterclockwise. Then you can know that the motor wire is connected wrong. You need to change the wire. After changing any 2 wires, let's test again. You can see that it is now turning clockwise. Next, test the next motor number 2. Tie the plastic tie to the motor. Motor number 2 should be rotating counterclockwise. You can see that the rotate direction is correct. Now it's the turn of the last motor 4. Tie the plastic ties on. Motor 4 should turn clockwise. You can see that now it's turning counterclockwise. It's the wrong turn. At this time, we need to reselect 2 wires at random and replace them. Now you can see the correct clockwise turn. After the test, the order is now counterclockwise, clockwise, counterclockwise, clockwise. The rotate direction of all motors is already correct. Finally, Use the plastic ties to fix the connection wires of the motor in turn. Trim off excess plastic ties.